getting things done with WAPTech. Amazingly enough, I do this. When I do videos, and if I have a complete failure of one video I just did, I throw it away and go on to do something different. Instead of trying the same thing that can cause frustration with some people, like me, sometimes it's better to just try something new. I'm going to make multiple takes anyway, so here we go. Steel pipe, threadings, bungs, caps, ends, standard pipe sizing, the history of it, some information, something better than the video I just tried to do that ended up getting hosed. Here we go. It came into being in the early 19th century. Pet peeve. 1800s. It's not the 19th century, it's the 1800s. You sons of bastards. Stop using the wrong number. It's not 19 anything, it's 18 something. All right? Carrying on. Lighting fixtures were supplied with natural gas as energy. Now, this is where people get confused, including on engineering pages. Well, it refers to the inner diameter or it refers to the outer diameter. They're both right and they're both wrong. Originally, the pipe was supplied from the brass mills because brass was used for natural gas because it wouldn't react badly. And also it was used on ships and for high-grade sewer pipes, by the way. Was supplied with from the brass mills in long tubes. The tubes were specified by their internal diameter because they would simply take a sheet of metal, wrap it around a mandrel, that's the inside pipe, and then weld the edges. And you could weld it all sorts of ways, but the easiest way was just to keep it hot and then press it together in a clamp. It would create seams on the outside, but the inside was nearly perfect. It might have pitting, it might not be perfect, but you get what you pay for. Next, the internal diameter opening has a direct bearing on the amount of gas that could flow through the pipe because it's LPG, low pressure gas, like 5 psi, 5 pounds per square inch. You can look at your natural gas lines outside. So you might want to look up gas pipe. This is also black iron pipe these days is said to be this. Here we go. Most fittings were brazed together to prevent gas leaks, so threading was not used much, and the threading would have been internal threading. And they welded them together by doing various tricks. One of the simplest ones was to grind, let's say this is the cross section of one side of the metal tubing, and here's the other one, like this. Let's do it this way. Here's your thickness. They would grind the edges like this to where it come to an edge, make it meet perfectly, and then hit it with an acetylene torch because that's made by throwing a particular type of mineral in water and getting gas out of it and then burning it with oxygen. Pure oxygen if you want to get hot. Ordinary air will also work as a blowtorch so that you get low temperature heating that can produce a black flame sometimes. And it would blow the metal in, and you'd supply another ring of metal on the outside. I've done the trick of taking the two brass tubings, this was for a different purpose, wrapping it with the brazing rod covered with flux that we painted on, and then just going around it with a torch or rotating it, and it would seal it almost perfectly. And the inside would have virtually no diameter change. And then we just polish up the outside because it was for making brass rails. Early in the 20th century, 19-something, you sons of bastards, electric lighting became popular. Electricians would look at the gas fixtures and use them as conduit for wire. Converting them by removing the gas nozzle and replacing it with a light socket was the easiest way to do it. And, here we go, after the electric industry made their own tubes, thinning out the wall thickness because it didn't need to be as thick, on the inside for more room for wires. So the outside diameter, whatever it ended up being as the standard for gas pipe in that area, became the outside diameter standard, and then the tubing got thinner, but the outside stayed the same because they put screw threads on the outside. Other companies did threading on the inside for anything large because it was fine, but they would do a ferrule that had an edge to it. Internal diameter became the best thing to keep it standardized with, for one thing, and threading it was extremely easy, but threading something in the inside has another characteristic that's a pain in the ass. The outside still has a gap. It's exposed to the elements, it's exposed to abuse, and it's exposed to tinkering or fiddling. And also, because of expansion and contraction, the inside threads are less metal on the inside than the outside. Threading the outside, making them to a standard, even if you had to force something this big to be this big to get it to fit, was easier. And you could still keep the internal diameter about the same. And again, like it says here, to fit bigger wires for higher current, for larger light sources, they used a similar outside diameter and just used the outside diameter only. Another thing, if you're not aware of this, putting a spline or whatever on the outside of a piece of tubing, even if it's just friction fit, is a lot stronger than putting it on the inside. This is from me dealing with tents. It's just better. It just ends up being, there's more material on the outside than there is on the inside. Pretty simple. Unless you're going to weld it, braze it, you're better off threading the outside. So the outside standard that was based on the inside was adopted. And these were brass tubing. So you will find brass tubing that says 1/4 inch, that's literally 1/4 inch internal diameter, actual diameter. And this is old gas fitting. That's the way it is. But the outside diameter was whatever the nearest size was that was highly likely not to fail and not leak or pit or chemically rack. They use brass because you use that on ships, saltwater proof, and it's generally tough. And if it breaks, it's soft enough, you can shut off the gas, bang the thing shut, hit it with a blowtorch, and solder it shut if you have to, or stick a plug into it because it's only 5 psi. You get the idea. So that's actually the story of why we have goofy fitting sizes that says 1 inch, and it only matches one thing correctly, the inside diameter of a Schedule 40 1-inch pipe. And also, even though it's supposed to say, well, this is based on the pressure, it isn't, because it works on plastic tubing, glass, everything. It's just a sizing standard, and it's something we inherited. The end. It was already standardized on the outside, so that's what they used. For convenience, threads were added to replace the need for brazing. Eventually, iron was used instead of brass to reduce costs because it became easier. And then eventually steel and stainless steel is used now instead of brass on coastlines. Sometimes gold-plated. Iron pipe size IPS standard came to be. Large pipes were cast in halves and welded together at the edges, and pipes' dimensions were sized by reference to the inside diameters of the pipes. Inside diameters under IPS were roughly as we know them today under the ductile iron pipe standard, DIPS, or nominal pipe standard, or National Pipe Straight, which is the actual name, which is stupid. National Pipe Standards is better, NPS standards. And also, it should be noted that IPS did not mean internal pipe standard, but that's also another name for IPS. Old copper tubing. Copper tubing is traditionally sized this way. Always specifies the outside diameter of the tube. IPS was originally an acronym for internal or iron pipe size as well. People just guessed at it and used that as the name. Fun fact, and then they made up a fun fact on the... Yeah, this was before the internet, and it was still something people did. See also Abraham Lincoln's mallet that is not anything like Abraham Lincoln's mallet. He was a practical person. Somebody made a video about how he invented a new kind of hammer that was made to where it had an impossible dovetail joint so that the hammer couldn't slip off the head. Meanwhile, everybody who's ever had an axe knows that it's made to where you drop the handle. You can get one where you drop a handle through the axe and it's just bigger at the top, or you can get one where it goes up through the axe and then you jam a wedge in it. This is not an innovation that's new. People have been doing this for millennia, making things fit and making things harder to break. And the actual hammer or mallet that Lincoln had was literally the most bullcrap grade hammer he could make that wouldn't break. It wasn't something elegant or clever. And Einstein's microscope is a dumb thing to look up. Just don't. Anyway, old copper tube standard is still referred to correctly. So you'll find copper tubing that's exactly the correct diameter, or not, because it might be too pipe standard, so they can get the threading to work. We move on. At Harbor Freight, Amazon, and other websites, you can get the following. This isn't really useful for most of the viewers, but I thought everybody would like having a trip down Agony Lane, 18th century. Stop using these numberings. 4th century BC. Fuck you. Give me a time and date stamp. That's actually very difficult if you're not aware of it, because we changed the time and date stamps because we found out we'd made mistakes for centuries and had to remove a few days from a calendar to get things to line up again. So there's an entire period of time where you can claim a date happened. It literally doesn't exist in time. Sort of like having your birthday be on a leap year day, on a leap day, but it's a year without a leap day. Most computers will let you get away with it. Just saying. So anyway, it can't fact check it, so it just doesn't bother. Harbor Freight or Horrible Freight, you can get taps versus dies. The taps go into something and make a hole. They're like a drill bit, but they're for making pattern of threads. And for pipe standard, it's a wedge fit where it's tapered, so that you put it in, you can put it in part way, and then it'll screw together, and it makes a really tight, usually water and airtight seal. And you normally make it in malleable metals so that they'll conform to each other, and generally they stay standardized. You can go from 1/4 inch, 3/8, 1/2 inch, 3/4 inch, 1 inch, and 1 1/4 inch tap to drill the hole into the inside of the pipe that you didn't know you needed, so you can do this weird sizing thing. Links below in the description. The whole set for all of those is $53. You can just get the dies on the outside at Harbor Freight, 1/4 inch, 3/8, 1/2, and 3/4 inch only. The other two are missing, for $15, because those are the most common sizes people ever put a hole in for pipe. Remember, this is for water taps and pipes. $50 with a 1 inch die added onto there, not the 1 1/4. So that'd be $103 for an entire set or something around there. For that same thing, but it has a 1 inch die as well. And it only does 1 inch down to 1/4. But it's $103. Amazon, a thing I can shop from that isn't automatically blocking me from viewing things, that doesn't go out of its way to put up pop-ups and demand I fill out a survey every fucking time. Amazon, the one I can actually navigate most of the time without it making me not able to, and just takes a fucking credit card and leaves me alone. Full set, $110. What do you get for this? 1/4 inch, 3/8, 1/2, 3/4, 1 inch, 1 1/4 for taps and dies. $110. What about the 1/8 inch? 12 extra bucks for the tap and die set pair. 1/8. So you literally get better range, and it costs you, at that point, $123, and you get all of them, and you only have to do 4 purchases. Tap and die for that weird small one if you need it, and the other ones are match sets, taps and dies, $59 and $50. Now, why am I bringing this up? I needed to find out if the tap and dies existed at all for doing water pipes and stuff like that, because I've had projects where I didn't want to use the little cinch together things, and because the pipes are similar, yes, you can just use the tap and die with a drill bit and make every pipe fit every other pipe, because you can make your own unions that fit inside of the tubing. By doing the inner diameter size that nobody ever uses, you can hide the threads, and then on the outside, you leave it open a little bit, and you fill the inside of it with, it's called tinning flux. It'll work on the ends of the pipes if you scrape off the, well, it'll have zinc plating. Do this outside. And then you squeeze them shut, and then you blast it with heat, and it will solder it shut to where it's nearly permanent. And then you can sand the surface of it, and you won't even be able to see that there was a break in the pipe if you cut them dead flat. The ream to make a dead flat like that, including one that suspiciously looks like one for making a specific size cylinder bore shit gun, was on the site, but I couldn't get me a straight answer on what all the dimensions are. But you can get one that flattens off the end clean and removes the burrs and lets you get away with soldering it like that. And it's tinning flux. Now, the reason I'm bringing this up is a lot of people wanted to be able to do these things in other videos, and they couldn't find the answer. So this is the video on how to do pipe fitting the modern way. You buy the tools and do it yourself, literally. Thanks for watching. Have a good day. Good luck with that.